So if x bar mean of a random size, so if you do a random sample and find out the mean of it, and it's taken from a population distribution with a known standard deviation, then the endpoints of the confidence interval for the mean or for mu, so mu is the total population then, so the population mean are given by this, so it's x bar plus or minus 1.96, so that's for the 95%, and then standard deviation over root n. So a random sample, so we'll just look at an example and I'll try to explain a bit more about what it's about. So a random sample of 400 oranges was taken from a large consignment. So you're only picking out 400 oranges out of a big massive consignment with unknown mean. So you don't know what the mean of the total consignment is. So you only but you do know the standard deviation, which is 15. So the mean weight of the random sample that you took of those 400 was 81.4. So this works out a confidence interval then for the mean of the total consignment. So if you just imagine a big factory full of oranges, and you just take 400 out of that factory at random, and then you know that the mean sample you took is 81.4. You know that the standard deviation of the total of the whole factory is 15. This works out a confidence interval for the mean of the whole factory then. So the mean is what you don't know. So it'll just be, it's basic enough when you're putting it into the formula, but it's problem here is more understanding what it's about and recognizing questions. So our x bar anyway for this one will just be 81.4 plus or minus, and then the standard deviation given it's 15, and over the square root of n, which is well, it's the 400 because 400 oranges out to test. So that's it. You can just use calculator and you'll come up with the confidence interval. So you should get 79.93 and 82.87. So that's our confidence interval and mean. So the mean of all of the oranges then in the whole consignment has to be between 79.93 and 82.87. Right, so here's another example. So a certain type of tennis ball is known to have a height of bounce which is normally distributed with a standard deviation of 2. So a sample of 60 such tennis balls is tested and the mean of the bounce is 140. So you're trying to know we want to get a confidence interval for the mean of all tennis balls then, not just the 60. So but we know that we've taken 60 out and we've tested them and the mean height of those bounces was 140. So we want the confidence intervals for all of the tennis balls then. So it's going to be just putting it into this formula again. So x bar plus or minus 1.96, and then the standard deviation over root n. So x bar was 140 plus or minus, and then 1.96. The standard deviation here is 2 over square root of, and then we tested 60 tennis balls. So that's going to be it. So we get 139.49. That's for the minus. And then for the plus is 140.51 when we round it off. So that's the confidence interval then. So we know that the mean of all tennis balls then has to be between 139.49 and 140.51, or we're 95% sure that it has to be between those. So that's it.